सारे देशवासियों को मेरे सलाम। इस देश के लिए दिए हमने भी जाने बलिदान, और हम भी शान से कहते हैं that I am a Naga. We are the Naga. We are the Naga. We are the Naga. We are the Naga.
One thing just describe.
check board next again first one. Check board. Pero tama assignment week ng once. Assignment check board. Ano po rin? Madin RP. Alexi. Ito section po. May section. Na ito section. Section. 이해하고 하고 그래서 난 저는 뭐 나의 아마 수능이 우리 텍스트라이션 뭐 그래서 Okay, let's start.
अच्छा बोलिए हमें मुझे निकला करो ना अच्छा अच्छा तो वो लोग अगर मैं मुझे एकला एकला
मुझे एक सेक्शन तो कहां एक सेक्शन तो अच्छा मदर आगे
हम टाइम दे दे एक्सपोर्ट हो
तब तो अपने डाउनलोड कर सुना इसको एक्सपोर्टिंग का डाउनलोड तो नेट लॉक कर देगा एक्सपोर्टिंग का नेट होना
600 MB अच्छी है
और देखो 850 MB में 1 or 2 or 2
Hello, ma'am. I think we can start now.
Yes, we will start after 2-3 minutes. Exactly at 1 o'clock.
Okay.
Okay.
One to be sitala develop later sana.
इनको फुटबॉल रेडियो से
Oh, it's the speakers. तो हम सब कुछ होला. Oh, ये caption दे ini.
हम
Ini videos
ने
ने.
हम जो पानी ना फेलियर ना होती है तो
Sir, shall we start now or will wait for 5-10
No
minutes?
problem from my end. You may start. From my end,
Okay, sir.
there is no problem.
Okay.
अच्छा एलके जी तो क्लास 7 तक इतना बोल रहे
Class 7 to.
हमें तो मालूम नहीं कि क्लास 8 का भी बच्चा ही बोलता है
Jadi, pertemuan tu chance kumti jauh.
अच्छा तो ये सुबह इना वाला अलग अलग चीज सुबह
मिडिल स्कूल बोलो हाई स्कूल 8 9 10 लेकिन 3 इयर्स तक मिडिल स्कूल
Ada reflection sana.
okay one week thumbs up dito तो भी लगना है वो
Oh, YouTube ke please.
Keystroke dynamics and security. Clear है? कौन से get started करते हैं?
अच्छा कुछ असाइनमेंट वगैरह इनमें नहीं पेट करो
So I think we'll start.
डॉक्यूमेंट सबमिट करना है इसके डॉक्यूमेंट लास्ट फिर करेगा और वो वीडियो अपन करना है जो ईमेल से सब सबमिट हुए उसे नहीं निकलना स्टडी करना और होता है जो लेने में चेक करना है और जब मैंने मैसेज से टाइप वीडियो
Kemudian biar Vicky bosan.
first year
कुछ assignment
Welcome you all back to this first session of 5th day. I welcome Professor Utpal Roy for delivering a lecture in the first session. And it's with great honor and pleasure that I introduce our distinguished guest and esteemed academician, Professor Utpal Roy, and who has graciously joined us today to share his invaluable insights and expertise. After the completion of his master's and PhD from the Department of Mathematics, Visva Bharati in the year 1994, he joined the University Laval, Quebec, Canada during 94 to 96 Later, he joined Indian Association for the Cultivation of Science, Jadavpur, Calcutta, as a scientist school, and subsequently he accepted the job of assistant professor in computer science in the Visva Bharati in 1997. Further, he worked as a visiting faculty in the Academia Sinica, Taipei, Taiwan during the period 2002 to 2003. Then he joined Department of IT, Assam University, Silchar as a professor in February 2008, and presently he is a professor and former head of the Department of Computer and System Sciences, Shiksha Bhavan, Viswabharati, with a 28 years of teaching and research experience. During this period, he published more than 100 papers in the journals of national and international repute. During this academic tenure, he guided six PhD students who are well placed in India and abroad. As a principal supervisor, he has handled externally and internally funded scientific projects. He has academic affiliation with many well-known universities and institutions. So now I welcome Professor Roy to deliver a lecture on keystroke dynamics and security in the modern IT world. Sir, now the
Yes.
floor is yours.
Yes. Professor Madam Sujata Das, many thanks for your nice introduction. And at the same time, I also thanks the Dean, uh, Professor D.K. Vidyarthi, and my mm, regards,
DK Winter
respect goes to the Honorable Vice Chancellor,
DK
Professor
Vidyarthi
Patanayak, and the participants who has joined today. Maybe all of you are teaching, working in some institution or universities and colleges. So we are all colleagues. I also belong to the same group. So thank you once again. Thank you, Professor Madam
Kalias.
Sujata Das. Now I may kindly be allowed to present my PowerPoint. So
Kali baru ngaji rest start 15 rest.
uh, is it visible to you all? Kindly. Hello? Hello?
Yes, sir, it's visible.
Visible to
Sir,
you
it is
all?
visible. Sir, visible. Your slide is visible. You are also audible, sir.
Okay. So my title of the topic is Keystroke Dynamics and its usability in modern age IT world. This talk is also supported by my scholar. First of all, let me tell you what the keystroke dynamics is. Keystroke dynamics is modern day is a very important and sensitive IT biometrics, IT oriented biometrics. I would like to mean the person we, when we type in keyboard, laptop, desktop, or in touchpad or touch screen in our smartphone, it has been now established that this typing pattern is very unique, and a person to person is very unique. There are no two person whose typing patterns are same. So this keystroke dynamics will be treated as a biometrics. How this keystroke dynamics can be exploited in modern IT world for user identification, authentication, and verification purposes. Throughout the talk, I shall just tell you my humble some findings. I shall share with you. Okay, so keystroke dynamics is the typing pattern of a human being that can be considered as a biometric to authenticate a user through his or her typing pattern on keyboard or touchpad or touchscreen, whatever. Now, this keystroke dynamics, this typing pattern, if we can catch it properly, then this can be exploited to an extent for identification and authentication and also in prediction purposes. Nowadays, we may know or may not know, our all smartphones are, all smartphones that we use nowadays are well equipped with many sensors, and has the keyboard where we type it with some pressure, we press with the fingers. Okay, now with these two means sensor family and our typing pattern together gives an important data, gives an important part of the keystroke dynamics. With analysis of this keystroke dynamics through various machine learning algorithms and technique, we can say that we can predict something accurately. We can operate something very many
Sensor
equipment
features.
and electronic gadgets with appropriate security. That I would like to say that all the world may be the typing, may be the password free. You need not remember any password. Machine will understand you. Machine will recognize you only through your typing pattern. When you start typing, machine will understand who is typing. If it's your smartphone, if you only hold, if you only type there, the phone will operate, otherwise the phone will not operate. Okay, this I would like to say. Okay, and we shall analyze all this thing through. And this is histodynamics is very cost effective. Means you did not put any cost in equipment or any other hand or lever that you can have to extract the typing data. It automatically can be stored in your machine, in your laptop or your smartphone. Okay, so there is no extra arrangement could be made to catch the data. And in course of time, in course of the changing of your typing pattern, machine will also learn how much is going to change and how, in which mm, direction the change is going. So typing pattern start nowadays, maybe after 30 years your typing pattern may change. But if you use the machine, machine automatically learn the change also. Okay, so machine will be able to identify you, recognize you, predict you, verify you to a change typing pattern in course of changing of your typing pattern. Okay, so this is the thing I am going to present before you. Okay, now come to the, this is the various sensors inside your smartphone. Okay, so here when we type something in the keyboard, the key, we do these four things mainly, mainly these four things unconsciously. The key hold, KH is my key hold time. Okay, then DD time and key down down time, up down time, up time. Then these are definition of digraph, trigraph, photograph, and etc. Keyhold. Well, suppose you type the cat, you will first touch the key C. C character you first touch. This is touch for some time. This is key hold time. And key down and then press the C to make it down. Okay. Then one character down to other character down is down down time. Up down time, up up. These are the feature vectors. Features vectors of your typing pattern. So while going something to analyze with the machine learning algorithm and machine learning technique, we need some feature vector. This is one type of feature vectors that your machine, desktop keyboard may or may not have sensors. But if you type with the smartphone, the sensor will also function. There are various sensors. Out of this, we consider here the proximity sensor, gravitational sensor, light sensor, rotation sensor, whatever it may be, these sensors that are also changing and course of time. If we collect, if we extract these sensors data together with the typing pattern data, together with this typing features, then a total keystroke dynamics is catched, is caught within your database. Now we have to analyze this database to an extent, to an efficient manner to do our job. There's a keystroke dynamics family. The static mode, if you type there a constant text, say your password is say Kolkata 123 is your password. So always type Kolkata 123. This is static mode. In the mm, while you are working with the laptop or your smartphone, always typing something. This is whatever you type, paragraph, long text, random text, whatever. This is the dynamic mode. So there are two type of mode, static mode and static mode means always you are going to type a fixed text. Dynamic mode, whatever you like, you need or do not need or in any need you are typing something, that's your dynamic mode. That typing may be meaningful, may not be meaningful, maybe random. Anyway, now with this keystroke dynamics, we can do these three things. We shall do it with three ways. First of all, verification. A valid user. You are a valid user or not? Your typing pattern is this, you have long database and your decision is there is a valid user or invalid user. It is one plus classifier. Restricted import, static mode, unrestricted import, dynamic, this whatever may be. So it is equal error rate. EER equal error rate is the one of the measurement metrics of accuracy of machine learning technique through which you will be identified. Through which you will be it is verification. Single user ID. With your machine, your phone, your laptop, your smartphone, while you type only, then machine will understand you through your typing pattern. Okay. Now, identification mode. In the identification mode, you have a lot of users. Out of these five users, the machine will identify who are you. Out of these five whose database are already stored, whose typing data is already stored in this database, within the database, out of these five machine can identify, out of this is the four one is who is presently typing is the valid user, is one plus classification. If this is be done with accuracy, parameters, measurement matrix is accurate. We shall all come to this point later on in detail. What is equal error rate? What is accuracy? What is AUC? AUC stands for area under the curve. So it is verification, identification, and prediction. In the prediction case, we can predict many things. We can predict the age group, you are major or minor, you are male or female, you are telling lie or telling true, your educational level, your handedness. Handedness stands for you during typing you use two hands. Okay, this handedness. If you okay, the hand used, handedness and hand used. You are left-hander or right-hander, handed, left-hander or right-hander. It is this handedness. This is left-hander, this is right-hander. Hands used. How many fingers you used while typing? Two fingers together. Okay, this is called hands used. With this technique, this prediction technique, we can predict many, even when traces your mental trace also. So in the typing pattern, mental condition also uh, puts some impression. It affects our typing style if how our mind is, mental state. Okay, your strong mental state, the typing pattern will change. That change can be easily catched with the mm, keystroke dynamics data. Even or all fingers are governed by some motor nerves. So Parkinson is the motor disease. Normally occurs after the age of 50. So any Parkinson disease person, if he types in the keyboard, or keypad. It Parkinson type. It Parkinson state of Parkinson disease can be detected. So in the early, so I just tell you beforehand that Parkinson disease cannot be detected in early stage in any clinical diagnosis. So through keystroke dynamics, the Parkinson disease can be detected early. We shall come to all these things later on. So in this stage, what we came to know that keystroke dynamics can be used for verification, can be used for identification, can be used for prediction. So verification in static mode means if we always type a static state, fixed state in dynamic mode, then identification in static mode, identification in dynamic mode, prediction in static mode, prediction in dynamic mode. There are 6 categories in 3 classes of applications. Hello, participants, am I audible to you all clearly?
Yes, sir.
Yes.
You are audible.
Okay. Next, come to the next transparency. It is it is the just survey. It is just survey. That survey says that these are the various methods and this identification in dynamic mode, identification in static mode, prediction in dynamic mode, prediction in static mode, which is the visualization in the dynamic mode and visualization in static mode. These are how much work has been done so far. So in desktop and laptop, this is in smartphone. This much amount of work has been done in desktop and laptop, this much amount of work has been done. And pie chart, this pie chart, this pie chart represents which algorithm has been used, how many percentage of that. Clustering algorithm, I'm sorry, clustering algorithm, this. Okay, so this here you are seeing the data of two types, data from smartphone, which environment it has been collected, a smartphone or desktop or laptop, desktop laptop or smartphone. This is in desktop laptop, and which classifier has been used, how much percentage. Okay, next come to the point, summary of meta-analysis. This, say, suppose in this here, in desktop and smartphone, there are two environments, desktop, laptop or smartphone. Say in desktop, design is verification in static mode, verification in dynamic mode. Say 30 studies has been done. The aggregate effect is 6.34. This variation is from 5.54 to 8.75. Matrix is equivalent and I square is the value of heterogeneousness, interclass variation. Is 100%. The tau square is a statistical parameter. It measures the degree of heterogeneity. So this table in fact says the summary of study that's already been done in various journals and various magazines, etc., about this keystroke dynamics. Now, shared data. There are the various shared data set available through internet. We have our own data set we have prepared, ROY keystroke dynamics in 21. These are the sensory data sets. Both typing pattern and smartphone sensor data has been combined here. So various character here are the various type of meaning. Say input type is complex, you type a complex text, mean with comma, full stop, numeric, non-numeric characters is complex text. Simple text means only in characters. Numeric text only in numbers. and simple text. These data sets have taken the complex text. I mean, they have typed such a text to catch the keystroke dynamics is a complex text. That text, that part of text contains characters, numeric and non-numeric data. Okay, this is Roy. This Roy data set is Kolkata, but it is sensory data set. Subject is 87. Mean 87 volunteers has contributed. Repetition means they have typed this text Kolkata 6 times. 6 times in a single session. Session means in a day or in a month, how many times he has typed. So here we have considered in a week, the volunteer has typed 2 times. And each time he has typed 6 repetition of the text. So in a week, he has typed 2 days, and in each day, the same text he has typed in 6 times. So 6 is the repetition. How many times in a single session the volunteer has repeated the text? This is repetition. Session. How many times? How many in different time he has typed the text? This is called session. These are the device characteristics. Means what type of keyboard? Keyboard are 2 types, you know. The first of all, if you see up your keyboard in desktop or laptop, QWERTY, the word is these 4 character, 5 characters are there. These are called quadri keyboard. There are some Azure keyboard, AJDRTY, Nexus 7 tablets, etc. There are various type of environment, these devices they have used. So these are the famous databases, balanced databases, okay, already available in internet. We have prepared a balanced database with many features and collections in with 787 volunteers considering male, female, minor, major, age, etc. And various level of their education and professions. Now come out to all these things. Now this is the metrics, how we will measure, how we will measure the performance of your model. There are 2 things, false acceptance rate, FAR. Number of falsely accepted illegal divided by total number of imposters, and falsely rejections rate means number of falsely denied. Try to understand my point. Number of falsely denied legitimate users by total number of genuine users. This is FRR, falsely rejection rate or false rejection rate. The curve goes in this way. Okay, this if you plot this curve, these 2 curves should cross in a point. Okay, this falsely rejection rate and falsely acceptance rate. So if these 2 curve at a point, this will call the equal error rate. Here falsely acceptance and falsely rejection are same. So this is called threshold. If I make this equal error rate very small, very less, then your system will be more and more secure. Okay? If it is very high, then if anybody can type your password, then equal error rate such will some of them will can get entry to the system. This equal error rate. First, I think all of you are familiar with this machine learning terms. Now, the performance matrix. This is binary plus the binary class classification. This is the confusion matrix. This stands for true positive. Suppose the male and female. The male I say 1, female I say 0. The system model is such that, okay, male, he has told the male to male, that's true positive. All male has been treated as male means true positive. Okay, some male, some female has been treated as male, false negative. Some female has been treated as male negative, negative. The false positive. some males has been treated as female, false positive. So this is called the confusion matrix. True positive, false negative, true negative. Some female has been called male, true negative. Okay, so in this manner you can understand this confusion matrix. So it's to measure the performance. Accuracy is not only the factor. Accuracy is this true positive plus true negative by true positive, false negative, true positive, a false positive plus true negative. Sensitivity is also an important factor, and specificity is also an important factor. Say, suppose for an example, try to understand me. Suppose you have 100 students in your class. Out of these 100 students, two are girls. If you run your machine learning algorithm, if if the algorithm says all are boys, then accuracy is 98%. Okay, but there are two girls also there. So accuracy is 98%, but performance is not good. Your minor class has been very much ignored by your model. Our objective is to here to consider the minor class also, to identify the minor classes also. So that's why these three these three parameters are equally important. Sensitivity, specificity are here under curve, and this is confidence interval, CI. Mean value plus this is standard deviation, etc. Now, here are various 1 plus classifier. Various, yeah, these are the definition of all these things. Minkowski family, Euclidean, Manhattan, Chebyshev intersection family, quad code family, and these are the Shannon entropy family, this combination family. These are the various one class classifiers that can classify an object class to its binary, whether male or female. 2 plus classification, sometimes it's called binary plus classification. Here, 50 classifier we have here considered upon this number of database. This number of database. Okay, these are the program has been done with our statistical language in a Shiny app platform. That program has been stored in a Shiny server. That is a free available server nowadays, very strong and accurate. We have put in the server our program, and the program has run with these 2, 3, 4, 5, 2, how many? 1, sorry, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 databases. With these 10 databases, performance is this. Now I have to analyze the performance. Means if we think of this is a vertical column, y-axis is equal error rate, x-axis is various the data set. It is a box plot. These are the box plot. Say it is a ROI. This ROI data set has been run. ROI data set has been run in ASCO group binary class classification model. In this, okay, okay, try to understand me. In this, okay, uh, in this graph, in each plot you will find it is a box plot. Okay, the equal error rate is here very less. Say it is the 0. Equal error rate is here. This 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 black line is the median line. Okay, and these two numbers are mean and standard deviation values. Show our algorithm, which is the algorithm? Bhattacharya distance is a 1 class classifier that is run with all these data sets. The output has been presented with a box. This is called box plot. This line is median line, and these two are mean and standard deviation. Okay, in each box, it meaning is the same. Our objective is to make the system more accurate. Is to equal error rate should be very small. So in this case, our database produce very less equal error rate in any algorithm. Any algorithm, raw data set produces a very less equal error rate. Equal error value is very less, so the model is very much accurate. Why it is so, I can explain, justify why this database produces very accurate. This has been prepared with sensory data. Mobile smartphone sensor data has been included here apart from typing pattern. The key up, key down, out, down, down, up, down manner of a particular character or text that when has been typed. Apart from that, sensor data has also been included here. So sensors are very perfect and works in the order of nanoseconds. So these data are very accurate. Now we may ask this question, sir, why these dots here? These dots are outlier count. Somehow, during typing pattern, your typing pattern may not match simultaneously same instant of time. Sometimes this data goes out. Sometimes. Okay, beyond. Now, come to the point. Next answer. Out of this 50 algorithms, 51 plus classifier algorithm, and the scale Manhattan algorithm performs much better. All cases, for all data sets, it performs much better. So I again say the program has been made with R statistical language. It has been stored in a synapse and it has been run with various and all statistical parameters of the R statistics has been. You may ask me, sir, why R statistics were used here for the purpose? R statistical language for the data visualization is very powerful. For data visualization and statistical analysis purpose, R statistical language is much more powerful, so far I know. And it is easy to program and install also. Next, these are the ROC graph. Okay, these are the ROC full form is receiver operating characteristic curve gives optimal cutoff value of a particular nature. With this, these are the various data sets. These are the detectors, autoencoder, outlier, and scale Manhattan. Okay, these are the three. This ROC curve. Okay. Next, come to the fact. Hello. Hello, participant. Am I audible to you all kindly?
Yes, sir, you are audible.
Yes,
Yes.
sir. Yes,
So,
sir.
in this transparency, I shall tell you that this typing pattern varies. This typing pattern, how that, what are the factors that influence the performance, influence the keystroke pattern. The complex text can influence the keystroke pattern. Only numeric text can influence the typing pattern. So the simple type can also influence the performance of the model. So complex text means I told you earlier, a volunteer is typing a text that are complex text. Here we defined it as a text containing characters, numeric and non-numeric characters also. Numeric text only numbers. Simple text is this. So this, if we consider these three texts, the performance equal error rate goes in this manner. In case of simple text, equal error rate is much more less. very less. So as equal error rate is very small, your system is much small stronger. The falsely accepted and falsely mm, rejected numbers are very less. So equal error rate is very less. If you remember my curve of equal error rate that I shown you my earlier transparencies, you can easily understand it. Now, next is comparing performance of the feature arrangement. All features, if you consider all features means what are those feature vectors that I told you at the time of typing? If you type some key, that is some key hold time, key down time, key up time, down time in a key. Suppose you first think logically you are typing cat, so you first press the C first, then down the C, then hold the key, then you press the A, then down the A, then up the A. If you in this here, if you measure all these things, these are called the feature vectors of keystroke denial. Apart from this, if you consider all sensor values during typing it change, then it is you are considering all the features of the typing pattern. Then the equal error rate is this. Equal error rate is less. Okay, the only down latency this is this. Only hold latency it is this. Only up down latency it is this. Okay, I told you it is a box plot again. Program is mainly art statistical languages. This is the mm, this black line is median value, red is the mean, is the standard deviation, etc. Next, come to this. How this input length? If the typing input length is larger, think logically. You are typing very only one character, one thing, two character, three character. The input length, what input you are typing in the keyboard. If this length is very small, the equal error rate will be very high. If it be then, if it increase gradually, equal error rate plus time will be very less. So depending on the input length, how much amount of character, word, etc. at the time we are typing. Next thing is important, repetition. While collecting a data set, we ask the volunteer to type a particular string of text. Okay, say 5 times, 6 times, 7 times in a particular session. Try to understand me. 1 second. While collecting data set, we go to the volunteer, ask him or her to type a fixed text. Say it she or she typed on Monday. Say Kolkata. Volunteer should type 6 times. 6 is the repetition. And if I go only to her on Monday or one day in a week, that is a session. Session is 1. If we complete it in a 4 week, session is 4. If we ask him or her to type this text 5 times in each session, this 5 is the repetition. If repetition increase, you say gradually the equal error rate get get fixed up, get stable. Equal error rate is high, then go became more stable. If we increase the repetition further, equal error rate will not change. These are the factors that influence the keystroke dynamics pattern. Now, come to the point. These uncertain changes in features. In a, you are say typing this text dot period. Okay, this text is this S0, S3, S. Try to understand me. S002, S004, 5, and 7. These are the name of some volunteers. Okay, these are the volunteers. Each volunteers has typed this text. I would like to say you in several sessions. In a case of single volunteers, while typing the same text, that has been changed also. That has been changed. Is a change that can change much also. The change can. I would like to say, if the same person types same text in different type, there is some change in the data, in the in their data. You may not time in the same keystroke dynamics. You may not time. You are unable to type in same keystroke dynamics in same text in several times exactly in same manner. As the manner changes, it also changes. You see, most of the time, most of the data are almost within the range. Some of them are going to outlier count. Going is beyond the box. That box, I show some dot points. The dot points are the manifestation of this variation. Next come to the say other point. This is the intra-class variation. Within the same class, you can also get the same variation. Intra-class variation is mentioned here. Okay, same person may have different typing pattern in the several sessions. This is also effect. So these are makes the Keystroke dynamics data set is very sensitive, very sensitive in nature. Okay, so these are the statistical variation occurred for same person, same text in differentiation. These are the proposed model we could here access. So we have now typing pattern. With the typing pattern, we shall now decide the access or the denied of a user. Okay, say how this data set is created is a claim sample. It is this is the claim sample. It is the claim sample. The sample goes to match with all these sample and concatenate the feature. Growing window technique is sample has been divided into several small samples of same size, and that template formation. Then column median is another technique that then this anomalous score. Then come to the decision authentication is score is less than some threshold. This threshold you can say your equal error rate value. You can increase or decrease. If you would like to make your system more and more strict, you can make this equal error rate value, this threshold value very small. Then if it reach less than or equal to this threshold value, answer is yes, your access is allowed. And if it is higher than this threshold value, the access will be denied. This is training phase, this is testing phase. In the training phase, machine is learn about all the samples with various techniques. And in the testing phase, is testing whether this sample is to that sample or not. If it, that sample to how much percentage similarity is there, that is incorporated in the threshold value. Threshold value, if you make it very strict, then your password will not allow you to sometimes enter the machine. Okay, this is the thing, logic behind. The performance of the Canberra with proposed template formation and adaptation. The Canberra box plot is here shown. The Canberra is the one out of the 51 plus classifier. This I have seen. We have seen the Canberra is the best performance, as the best performance. Now these are various types of impact of template adaptation with repetition. So with number of session, the equal error rate get decreased. The first session, second session, third session, fourth session, fifth session, sixth session. The equal error rate in these directions. Okay, this direction it is going to be decreased. Okay, this is the session, number of session. In a same session, if you increase the repetition, the equal error rate will gradually increase. You can understand it logically. You can understand this thing logically. Okay? Now, active user authentication. What I would like to say. You will use your smartphone, use your laptop. The active user, you are unconsciously machine will authenticate you. Okay, machine will unconsciously, okay, you will not type any fixed state, etc., etc. Machine will type whatever you like. Machine will learn your typing. And active user authentication is this. Okay, a predefined sequence of input choice is inappropriate for re-authentication. Okay, KD-based active authentication validates the genuineness of the user throughout a session by monitoring continuous typing activity and re-authentication technique. Now, this is a trade-off between security, usability. So, if you increase the security, usability will be less. If you increase the data acquisition time, your usability will equally be less. Battery power consumption is the fact. The sampling rate and duration is depends on the battery power. These are the three parameters between the trade-off. If your purpose is this, the usability must be high. Okay, so then you have to compromise with the security, data acquisition, the duration and power consumption also. Next come to how we access data. Here participants, am I audible to you all kindly? You,
Yes, sir. Yes. You
hello?
are audible, sir. You
Are
are
you?
audible.
Okay.
Yes, sir. You
This,
are audible.
this tube which is moving in the screen where we catch the typing pattern. This is a tool. This is a we have developed the tool with Java programming. While you type it, you when you will type it, it will capture the data. You type your name here, male, gender, and then the specific text that is that will how do we capture data? Okay. Uh, Now this is windowing technique. We can divide this data in various windows, a particular duration of time window. We have divide partition this data in 1, 2, 3 part. Okay, so this windowing technique, then comparison baseline of other three approaches. This is a state of the art approach. Autoencoder, Canberra, cosine, these are variables, one class classifier, detector, and the state of the art performance, median and augment performance, short biometric included. These are the values we have obtained with equal error rate with some standard deviation. Okay, the soft biometrics inclusion, this equal error rate get much less. Okay, augmented sample is this and it is going to be much less. This then performance with approach 4 and score fusion. So we have three approaches. If we fuse the score of two or more approaches together, the the performance will also increase. The performance of other scheme with approach 4, ensemble approach and scale Manhattan approach out there count considering this will approach will like this. Now come to the phase of proposed approach. Okay, phase of proposed approach is this. This is the windowing technique. So a data has been partitioned with various pairs, and with this technique, the data has been augmented. So this small number of data, large number of data set has been prepared. This augmented, this is called augmented data set. With this augmented data set, this the input layer, this is a hidden layer, reconstructed layer, and trained classifier, anomaly detection technique, this test sample will come and this will give the score. This similarly, if this threshold is beyond some less than some value, the system will allow you to access, otherwise not. Okay, now table duration fixed the data acquisition duration as influenced by various factors. This p value. Now come to the other point. Now this is the table which shows that how uh, soft biometrics can influence, how soft biometrics can influence the performance. Okay, this is a qualification, age group, handedness, hand use, gender, and residual. These are the various soft biometrics. This group is there. Standard deviation is this. Inter plus correlation coefficient is this. These are the various performance, important performance. The influence of soft biometrics in the performance is something like this, as shown in the extracting useful information. Sometimes we use bootstrap sampling to make analysis of the imbalanced data. Imbalanced data means all classes are not properly manifested in the data set. So here, if you say the yellow person is per concentration, there's only here
World Cup to match
yellow
la
person,
aji ase final.
4 per concentration. Others are no.
England or
Others are
Spain.
healthy one.
Paris
So
ho para
to
nahi.
bootstrap sampling, we do
Rồi
this
नहीं precise हो मुझे नहीं किधर.
bootstrap sampling considering all these. Okay, considering in this manner, it is the
India la mutahan berapa
rare sample are ignored. Rare sample are less in each bootstrapping sample. So unrealistic higher performance in traditional model, this vacuum, etc. Presence of several samples in multiple sessions with the overlapping sample with both training set and testing set. This is the bootstrapping sample. We have prescribed a special bootstrapping method here in our technique. The existing conventional bootstrapping method is this. Rare samples are equally divided in all bootstrapping samples, almost equally divided. So here we consider 3 bootstrapping samples. 1, 2, 3. Out of these, 2 has 1 and 1 minor class, and third one has 2 minor class data. Okay, here I solve the yellow persons are with percentage. But we do the bootstrapping sampling here in this. All the bootstrapping sampling contains all the rare samples, and every bootstrapping samples are balanced. So here we take the 4, here we take the 4, here we take the 4. All these bootstrapping samples contain equal number of rare samples, minor class. Okay, this is our proposed technique. And with this technique, the training set and test set does not contain the same data. LOUCV, leave one user out, leave one user out. Okay, this is the LOU. Maybe these evaluate the proposed model with the more realistic model evaluating you leave one user out. Okay. Now this is the voting model. Which model gives how much positive vote and negative vote to the sample? Major voting system. Okay, so these are the sample raw Keystroke dynamics data sample. This is the majority class sample, minority class sample, the sample separation. Out after having majority class samples and minority class samples, we goes to the bootstrap sampling, bootstrap sample 1, 2, 3, n, etc. Majority class, minority class, we run with various models, machine learning model. They are provide either yes or no. So if majority voting system, if the most of the model gives the positive vote, yes, binary class yes, or no. So this is the final outcome with 0 and 1. Actually, it is like this. That these are the samples. The here out of this, the A1 is the testing set, others are training set. B is the testing set, others are training set. Same sample type. B is the testing set, others are training, and so on. And we go award and subject is aim. So there are the actual level is 1 1 1 0 0 0 1 1 1 in the sample. So after predictive score, if we got the